Okay, today we will learn about graphs. Okay, so if you look at a reaction rate graph, okay, I have plotted for you this graph. Okay, and this is the graph of concentration against the time. Okay, for cyclopropane. So I have plotted this graph for you, and then you can see that there is going to be a curve, okay, that is being formed from this graph, okay, from this concentration graph, okay, against the time graph, we can actually get the rate of reaction, okay, because we can actually find the gradient at specific points in this particular graph. For example, if you want to find the gradient at a specific time, for example, at time 20, so we can actually find the gradient at that particular time by drawing a tangent, by drawing a line where it just touch at that one point, okay, of that I've shown over here. So for example, let's say we want to draw this tangent. So I will actually show you. Okay, so let's say we want to actually draw a tangent. Okay, I'm drawing like this. This is going to be a straight line. Okay, I will actually draw this first and I will try to bring this line. So this line should be touching at that one point. Okay. So roughly, okay, you can see that, okay, if I adjust a bit, okay, it is touching at that point. Okay, touching here. So therefore, okay, this line can be used to identify the gradient. Okay, in this case, if I draw a triangle, okay, I can draw a triangle over here. So this triangle, we can use it to find the gradient. So how to find the gradient? Okay, the gradient is going to be, we find what is this point. Okay, let's say I assume it's going to be somewhere here, 0.9. Okay, this is 0.9 and this is 0.4. Okay, 0.9 minus 0.4 is going to be 0.5. Okay, that's going to be your y, okay, difference in y, and this is going to be x. So if you see 10 and then you have 30 over here, so it's 20 minutes. Okay, so if you divide so divide by 20 minutes if you want to change it into seconds. Okay, 20 times 60, so you can actually do that. So quickly I will actually calculate this. Okay, 0.5 divided by 20 times 60, and you will get 4.167 times 10 negative 4. Okay, the unit for this is going to be, this is going to be the concentration, so this is going to be mole per dm cube, and this is going to be second, so the unit will be mole dm negative 3 per second. So that is going to be how you are going to actually draw, okay, the gradient. And this gradient represents, okay, if you look over here, this is going to be concentration divided by time. And we have learned that, okay, if you have rate is defined by concentration, change in concentration divided by time as well. So this is going to be actually the gradient represents your rate. Okay, the rate at that particular point, which is going to be at when the temperature is 20, when the time is 20 minutes. Okay, the rate is going to be 4.167 times 10 negative 4. So you can actually use this method to find all the rates, okay, at any specific points in this particular graph. Okay, like for example, if you want to find the rate for this point, let's say somewhere here. Okay, so you just need to actually find, okay, a tangent. You need to draw a tangent to that point over there. So roughly if I just put it here, okay, you will get a line over there, and then you need to just form a triangle. So probably I will draw a triangle. The bigger the triangle is much more better. So in this case, roughly I'll show you. Okay, you can actually find what is this, and you can find what is this. Okay, you will be able to find, okay, if this is y, this is x. Okay, and you will be able to find the gradient. Since this gradient, okay, is going to go to the left hand side, okay, it's more towards going this side, so this one is a negative gradient. Okay, you can put the negative over there. Okay, so now I want to also show you about initial rate of reaction. Now, in the initial rate of reaction, normally we use initial rate of reaction to identify the rate of reaction at the beginning of the reaction that is taking place. Especially when you have a particular reaction, if you enlarge this, okay, it will look like somehow there is going to be some sort of a straight line over here. Okay, so we will actually use initial rate, okay, to find out, okay, what is going to be the initial rate for each reaction. So in order to do that, okay, it's a similar way. Okay, we will draw a tangent where it touches at this particular point at the beginning when time is going to be 0. So if I use let's say I use different color, okay, maybe I'll use blue. Now, so if I want to draw, okay, a tangent over here, I will try to draw a tangent. And you can see that it touches at this particular point. Okay, so you can find out, okay, from this triangle, you can find out what is going to be your initial concentration. For example, from this point to this point, this is 1.5, this is 1, so this is 0.5. And this is going to be, this is going to be 5 seconds, 6, 7, 7.5, yeah, 7.5 seconds, 7.5 minutes over here. So you can calculate, okay, in this case, if I want to find the initial rate, my initial rate is going to be 1.5 minus 1, so it's 0.5 mole per dm cube divided by 7.5 minus 0, yeah, 7.5, but I want to change it to seconds, okay, times 60. So if I could quickly count 0.5 divided by 7.5 times 60, I will get this 1.11 times 10 negative 3 mole dm negative 3 per second. Now this is going to be your initial rate. Okay, take note, the initial rate was negative 1.1, and you can see that, okay, you can see from the graph itself, okay, the gradient, okay, as the reaction progresses, you can see the gradient is going to decrease. Okay, so you can see that it's going to be less steeper. Okay, it's less steeper than it used to be. So you can see bigger number, 10 to the power negative 3. And this is going to be smaller, 10 to the power negative 4. Okay, you can see the rate is going to decrease, okay, over time. But anyway, this is going to be how we find the initial rate. Okay, take note of that. Now, for these particular reactions, okay, for reaction rate, we are going to focus on three graphs. Okay, sorry, we will focus on two graphs actually. Okay, the graph that we need to focus is going to be, one is going to be your concentration against time graph, concentration against time graph, and second one that we are going to focus on is going to be your rate against concentration. So very important, okay, very important. So these graphs, okay, we need to focus on, okay, like for example, if let's say we are talking about reactants, okay, so we know that, okay, if you use a particular reactant, okay, we know the reactant will decrease, okay, for example, A plus B to give you C plus D. Let's say we are talking about concentration of A, okay, so here, okay, what is going to happen here is going to be the concentration, because A is going to decrease, okay, there's a few ways, okay, the concentration can decrease over time. Okay, one of it is going to be it can decrease using a curve, okay, like what we observe in this particular graph. Okay, so you can see it is a curve. Okay, but apart from that, okay, you can also have the concentration to decrease in a different manner. Okay, it can also decrease in this way. It's a straight line graph. Okay, it's going to decrease in that way. Or you can also have a graph that is going to actually decrease way steeper, something like that. Okay, let me draw again. Okay, so there are three types of graph, okay, that you can actually have. This is going to be if later when we learn about order of reaction, okay, we will actually look at this. Okay, this is going to be, if it is a straight line decrease, okay, that's going to be a zero order reaction. Okay, zero order reaction. And this one we will learn later. Okay, we will learn later. The one that is going to be steeper, we will actually call it as a second order reaction. This is going to be first order reaction. So we are looking at two types of graph. Okay, one is a straight line and another two will be curves. Okay, so the zero order, okay, we will actually have a straight line. This is because, okay, when you look at the concentration against time, this is because if you calculate the gradient, okay, for zero order, the gradient is constant because it's a particular gradient. So therefore, if you actually look at a gradient, which is a rate, okay, so if you, the rate is constant, okay, it doesn't matter, okay, the change in concentration of A. So the rate is going to be constant. So if it is a constant rate, that is going to be one graph that we will get like this, a constant rate. So this belongs, okay, this belongs to zero order. Okay, this is going to be zero order reaction. And we also have another two more graphs, okay, which is going to be, one is going to be the rate. The rate can actually be a straight line graph, okay, so it means when the concentration increases, the rate actually increases proportionally. So we will actually have something like this graph, okay, it's a straight line graph. This is going to be a first order reaction. And we also have a second order reaction. For the second order reaction is going to be something like a quadratic graph, okay, because it follows, sorry. Okay, it's a quadratic graph. So this is going to be a second order reaction. So there are three types, okay, of graph for each of the graph. Okay, so you can see for concentration against time, you have this particular graph. For rate against concentration, you have these graphs. So these graphs are very important. So we need to take note of this.